today. I'm with Kenji Sugahara and Vic Moss from Drone Service Providers Alliance. How are you both today?
Doing well,
Great.
thank you.
Great. I'm going to have you both introduce yourselves and tell you a little bit about what you do. Kenji, let's start with you.
Sure. I'm Kenji Sugahara. I'm president and CEO of the Drone Service Providers Alliance. I'm a lawyer, longtime drone pilot, and actual commercial pilot full time with drones.
And I'm Vic Moss, the COO VP of Drone Service Provider Alliance. And I too am a drone pilot. I'm a photographer and videographer by trade. Drones are part of my toolbox for what I offer my clients.
Fantastic. It's great to have you both here today. And Vic, can you tell me a little bit more about the Drone Service Providers Alliance?
Sure thing. Kenji and I started the SBA earlier last summer and just kind of wanted something to have an official voice for the small and medium sized drone service providers. We've got AUVSI and Commercial Drone Alliance. Those guys, which do a great job for the larger manufacturers and the larger drone service companies. But we felt that there really wasn't a great voice for the smaller operators. So that voice seemed to be getting lost a lot. So we wanted to try and become that voice.
It's great to see that kind of support happening at that level. Kenji, can you tell me about the role each of you played during the remote ID role development period?
Sure. So originally, I was part of the 2017 Aviation Rulemaking Committee on Remote ID, and I had brought a white paper on using Bluetooth for remote identification to the ARC. Uh, and throughout that process, I helped write the technical paper for Workgroup One, which was the technology side, and then I actually helped draft the final product too, which you actually see written. Subsequent to that, I was involved in introducing ASTM to Gabriel Cox from Intel, who had sort of created some framework about Bluetooth for remote ID and remote ID, and that's sort of how remote ID ended up in ASTM. There we started the development process in terms of industry standards for both broadcast and network, and then continued that work till to today. Oh, and one thing, Danielle, I forgot to mention that both Vic and I are part of the FAA Drone Advisory Committee too.
And it sounds like you've been with this since the beginning. Vic, do you have anything else to add about that involvement?
No, it was, we were hoping one of us would get on. Kenji actually is on as DSPA. I'm on as owner of Moss Photography. That's a distinction with a difference in that, I'm not part of DSPA on the DAC. I'm a commercial drone pilot rather than the voice of the smaller organizations and stuff.
Yes. And one other thing, Danielle, we've actually been involved with the DAC for quite a long time now. And that involvement stems from the task groups, which really looks at the issues that the DAC addresses. Vic, you were on the waivers task group,
Right.
correct?
Hmm.
Yep. And then I've been involved with the UTM ConOps 2.0 review, where I'm on task group 9, which involves sort of looking at how remote ID information can be used by low altitude aviators and a couple other task groups at the same time.
So, Kenji, can you kind of talk about what we mean when we say broadcast versus network? And, broadcast kind of breaks down into either Wi-Fi or Bluetooth. And what does all of that mean?
Okay. So there's listening to some folks on the internet, they confuse the things and they sort of mix and match terminology. So hopefully this will help clarify things a little bit. So the idea behind broadcast is you are just sending out, or your drone is just sending out a signal with a specific data sets like high altitude, your drone ID, your vector, and all that information. It's going in one direction. Okay. So it doesn't matter whether there's a receiver on the other end. It's just sending it out no matter what. Okay. So that's basically what broadcast is. A drone saying, I'm here, I'm here, I'm here. This is my ID. Um, Network is a little bit different. Network is you actually connect to something, and there's bidirectional communication. So that it's going information going back and forth. So that connection happens over really any type of network, terrestrial network. And you're talking LTE, like your cell phone connects to a network, or you have a satellite phone that connects to a network. So your drone is actually communicating through the internet, through LTE to, say, a server or something like that, which would store your information and such. So basically, that's the difference. Broadcast, I'm here, I'm here, I'm here. Network, we're talking together. So that's the difference.
Fantastic. And if we say Wi-Fi, is that network or is that
Well,
broadcast?
the way the broadcast is implemented in Wi-Fi, it's unidirectional. So if you think about it, when you're on your laptop or something like that, and you're out and about, you set it up, you want to connect to a network or whatever, um, you see an SSID. And the way that the Wi-Fi works is it's packed all that information about your remote ID into that SSID. Remember, you don't need to connect to that network to get the SSID. The router is just sending out that SSID. It doesn't care whether anybody's listening on the other side or not. So Wi-Fi is broadcast, and the implementation is there's no two-way communication. It's just one way, just one way. Quick other thing too. The reason that Bluetooth and Wi-Fi are they weren't in the rule, if you notice that, but
I did.
it's pretty much one of the only ways to comply with the rule, because the technology has to be compatible with a mobile handheld device. That was one of the primary concerns, was the price of a receiver for law enforcement, hence the handheld mobile device, because everybody's got them. Now, the specific implementations, um, there might be a little bit issues with Bluetooth 5 because in the specific protocol, because some current cell phones or older cell phones might not be able to receive it. The Wi-Fi, everybody should be able to receive it, but there's some specific protocol questions which I talked to a sort of um, engineer if you want to really get into the guts of it. But yeah, it should be compatible with most handheld devices at this point, but just be aware, not every single cell phone will be able to pick up on it.
No, that's good to know. So since you've both been in this since the beginning, can you talk about why there was concern about network during the commenting period?
Absolutely. Network seemed to be one that was going to go ahead and just add a layer of confusion and a layer of issues to the small and medium sized drone service providers. We were going to have to be able to have adequate network capabilities, and when we didn't have network, we would have to do some additional things, and then also the subscription that would have to go along with it. So the technical aspects and financial aspects were not really what any of us were looking for.
Yeah, and to follow up exactly, one of the biggest considerations was cost, especially because it would increase the cost of drones quite significantly. The cost to put in an LTE modem, plus the recurring fees to actually connect to the cell network, were costs that were fairly significant. The other concern that we had as drone operators, and not only for us as commercial operators, but also for the recreational folks, was the big brother aspect. In some of the cohort meetings, there was discussion that three-letter acronym agency wanted a dashboard of the sky, and that would include tracking not only us as operators, but including that 8-year-old kid who's flying in their backyard. We thought that was a lot of overreach, and it was for us. We felt that if you're in the middle of nowhere, nobody really should have to know what you're doing if you're not affecting anybody else, especially somebody out in DC or something like that.
Mhm.
If it was local law enforcement, great. If we had no problems with that as long as it was localized.
Understand. Um, so what are the capabilities of broadcast now that we've gone with that broadcast route? And how does this enable the growth in the commercial drone industry?
It's the capabilities are actually kind of nice because they're limiting, um, in that whether it's going to be Bluetooth or Wi-Fi or whichever one they're going to use in that particular system, it's all line of sight. It's not very powerful, and so the ability for people to find us is going to be there. For those who need to find us, first responders, things like that. Somebody sees a drone and they're flying over their house, they can pull up their app and say, "Oh, okay, well, I'm not worried about it," or "I am worried about it," and they'll go talk to us, or something along those lines. So the fact that it's not just going to be this all-encompassing, everybody knows where we are, whoever wants to know where we are. I think that's probably the biggest issue that we prefer over the network side.
Mhm. And one other thing to add on to that too is there's this misconception that you need network remote ID for UTM to function. That's actually incorrect. The whole purpose of the UTM structure is to share intent, and it's sort of the idea of strategic deconfliction in terms of and what that means is sort of pre-planning so you don't interfere with each other. One of the most interesting things that has come out is in the UTM ConOps 2.0, which is a document that the FAA put together. Visual line of sight operations are treated differently. And the reason that they're
Mhm.
treated differently is you can actually, the remote pilot can actually see the drone and can see and avoid other aircraft. So there's a conscious decision to sort of separate that from having to connect to a network and be involved in it. There will be some sort of UTM participation, and that could be through, for example, Lance, which is the low altitude and notification system that a lot of us commercial operators utilize, or going through Drone Zone for authorizations and such. So there are ways to participate in the UTM structure without having to be connected to a network. The other thing that's a possibility too is there is what's called secondary surveillance, and there's a few companies out there that are sort of working on this issue. And what that is to be able to take that broadcast remote ID information and then sort of receiving it and transmitting it to the UTM sort of system. And if you think about it, what it is a distributed network of sensors. So say, for example, there's some critical infrastructure. You could have a whole bunch of sensors around there. And if there's a drone flying around or whatever, it could broadcast to these sensors, picked up, sent onto the network. And you can actually do that throughout a city where it might be important to have awareness of where drones are flying. So it is possible to get broadcast remote ID information to a network. So that in itself will enable sort of the advancement. There's also a couple other considerations in terms of um, manned aircraft too, because uh, outside the Mode C veil, there is no requirement for manned aircraft to have ADSB. So talking to with AOPA, which is a sort of a group that represents GA pilots, they don't want to add ADSB to those aircraft. So the question is, how does those beyond visual line of sight delivery drones pick up on the GA aircraft? So that can be done through either a couple ways. You can have that secondary surveillance through radar where they're picked up and then broadcast to UTM or sent over to UTM. I have to be careful because broadcast has specific terms. Um, or the other way is that there's sensors on board these delivery drones and drones that fly beyond visual line of sight. And talking with AOPA, that's sort of been their expectation, that there'd be sensors on board. So again, that means that there's the participation in UTM to sort of avoid each other is not required, because the visual line of sight drones can be avoided by these delivery drones, and that's sort of the technology that's out there.
Interesting. So what you're saying is, you're talking about the cost of where that networked capability is, instead of putting
Mhm.
it on the drone where the cost is and everyone has to pay into it. You're looking at infrastructure, places that need to protect their own infrastructure and be able to detect
Yeah,
that
yeah.
to start putting that money into the infrastructure in that side of the
Mhm.
industry instead. Is that kind of what we're thinking about here?
Yeah, yeah, yeah. Because what it is, it fundamentally it's a cost shift. It's the question whether the remote pilot has to pay through subscriptions and such, or whether it's the actual consumers of the data that need to pay for it. So you think about it, the critical infrastructure folks, they want to protect it. They want to know what drones are around. So instead of having every single drone op have to comply with network, they just need to broadcast, which is cheap and it's simple because the cost of the chips is really low. And instead, if the folks at the critical infrastructure want something, they'll have to deploy sort of receivers around the perimeter of where they want to secure. So for us, at least, I think the cost is put where it appropriately is.
Mhm.
Now, the other thing too is on the security side for law enforcement. That was a big consideration during the aviation rulemaking committee, and that's why cell phones were chosen as a receiver, as the lowest common denominator for a receiver, because everybody has them. And a lot of small departments, you're talking around one or two officers, so don't need or don't want to carry around these huge, high tech, expensive rigs to detect drones. So the cost, of course, was a huge consideration. And Vic, do you have anything to add on that?
No, I don't. And even when you're talking about adding something like this to a critical infrastructures already have a security perimeter. They've got either the motion detectors or the cameras or something like that. So they already have a network. So it's not like they have to go build from the ground up.
Mhm.
The cost to them would be actually a lot less cumulatively than it would be to cost to us. All they got to do is adapt what they already have, and if they don't have a security system already, are they really critical infrastructure? So I mean, it's got to exist already. So all they have to do is adapt it, which is going to be much, much cheaper than a ground up build.
Yeah, and one of the other options too is put sensors on the Wi-Fi or Bluetooth RF detectors, or sensors on telecommunications infrastructure that's already there. So like cell
Mhm.
towers. And guess what? You have a connection to a network right there because they're already connected to a network. So that would be an easy and seamless way to do it. Of course, the question is who's going to pay for it. And again, I think the consumers of the data, it'll be incumbent on them, or a company that wants to do it really gets to install those.
Excellent point. And it's putting the cost where people are more likely to want to pay it. And do you ever see a situation in which we have to start talking network, or is this really kind of broadcast is really the best way to go?
Yeah, for advanced operations, I can see how nowhere in the NPR or nowhere in the final rules, sorry, not NPRM, the final rules does it say no network. It says for now.
Right.
And so, yeah, network's going to happen, but at what level and for what operations? For the advanced operations, BVLOS, yeah, I mean, it seems almost like a no-brainer that those type of situations would have to be hooked up somehow to some kind of network so that information can get out.
Yeah, and I agree, and I agree 100% on that. And as Vic said, the final rule did not say no network ever. Eventually, that will be implemented likely when the technology is ready. The things that it can do are fairly interesting. The strategic deconfliction is
Mhm.
is an amazing way to sort of pre-plan flight path. So it's called like 4D planning. So you have three dimensions plus time. So it's a moving reservation uh, in space, and that's how a lot of Amazons, the Googles, the delivery drones are going to separate from each other. They just pre-plan, and the there's going to be need to be some rulemaking from the FAA, both on BVLOS and UTM side, just so there's some structure. Because otherwise, unless there's that structure, an instruction set, it's very hard to come up with standards for it. Um, there's already been work on the ASTM side for network remote ID, and you can really leverage that for sort of UTM, the UTM architecture. You're talking about like their inter USS protocol as an example that Google came up with to sort of ease that communication between sort of UAS service suppliers. That's what the USS stands for. So that communication between them, so they can share that information. A rule around that again would cement it, get everybody on the same page, and that would also help sort of drive our industry forward.
Excellent points. So when are you expecting these types of technologies to start to be available to the drone community? I know there's a lot of steps, and I know that we have these deadlines that are set forth by the FAA. But realistically, when can people start planning on seeing some of these things?
Vic, I'm going to let you talk about the
Oh man.
deadlines, just to remind people.
Well, obviously, 18 months from from this March is the manufacturer deadline, and then the year after that is the everybody has to fly or fly to FRIA, um, with very few exceptions. But as far as the technology itself coming out, got to wait for ASTM standards, and those should be out whenever. Kenji can answer that one a lot better than I
Oh
can.
boy, yeah.
But once those are out, then yeah, the manufacturers will have their stuff ready. I mean, odds are, if it's not like this fell out of the sky December 28th. Everybody knew it was coming.
Right.
Everybody knew when it was coming. So all those manufacturers are okay. It's probably going to be this. So let's go to this far with our research, maybe even the manufacturing, and then once we get the actuals, we can go ahead and tweak it where we need to get it out on the market. So I don't think it's going to be that long. They have to get ASTM has to do their thing, FAA has to do their thing, and then the manufacturers have to do their thing and send it back to FAA for approval. Then the FAA has to approve. So timelines, Kenji and I disagree about that, but go ahead, Kenji.
Yeah. So we've already started meetings. This will be good information for the folks who actually know what's going on. We started the ASTM process back up because we had that original standard that we came out with late last year, and we knew we'd have to revise it for the final rule when it came out. Now that we've had time to analyze it and take a look at and figure out what we needed to change, we started that process. But ASTM is a very consensus-driven group, so we're hashing through some issues. There's some interesting issues cropping up which we need to get through. And any group, that it just takes time. It's the FAA gave us sort of a time frame. Will we be able to make it if we remain disciplined? And in any group, that's kind of hard, but we're doing our best to do it. We're hoping to meet it. I'll make sure that I'll do my best to make sure that it stays on track, but it's a process. Hopefully within the next 6 months. Um, as far as your question about some of this technology, when will it be implemented? Uh, it's a long-term process. I mean, remote IDs is the low-hanging fruit. That's easy. The cohort, which happened last year, really shows how far we are from an implementation. You're not only talking about figuring out network where there's sort of information or actually signals lacking. You have to map all that out to figure out where you're going to have sort of command and control functions. But there's a lot more parts than people think there is. So maybe 5 years, 7 years, that wouldn't be out of the question. So just keep that in mind. Nobody can really come up with give you a firm number at this point because it's continuing in development.
Absolutely. I know everyone's hungry for those dates, but the real honest answer is always it takes time, and we
Yeah.
gotta test all these things. Each time you get
Yep.
through, you have to make sure it works before you go to the next thing. Rushing it doesn't get us very far. So I'd like to get both of your final thoughts about remote ID and where we are today. Since we just looked into the future, let's talk about today. What are your thoughts about where we're at?
Oh gosh. I always like to somewhere in one of these conversations just make sure people understand, don't panic. There's no need for panic. We don't have to freak out about anything. We have lots of time. Um, we might look backwards on it and go, boy, that wasn't much time. But looking forward, yeah, it's we have a lot of time to get everything right. Everything has to be done right. You can only do it right the first time once. So I've always been for remote ID. I might be one of the only ones like that, but the concept of remote ID. Let me put it that way, because it's needed. It really is needed with where we're going to be in a few years. You got to get it working before we can move steps forward. So where we are right now, I'm pretty happy. We have some issues still to work out. Drone pilot safety being one of them, but we'll figure it out. I'm confident and I'm optimistic, but I'm optimistic by nature. But I think we're in a good place with remote ID.
Hmm. And
Kenji, what do you
and
think?
and I agree. It's definitely a good start. The remote ID can be improved. For example, I think notify and fly, which is you go on an app, just say where you're flying, what time, what aircraft you're flying, uh, would have been great. And I see that as an improvement. And I think there's industry sort of backing toward that. And I think a lot of people who fly for a living would actually appreciate that too. And that fundamentally sort of fulfills the security requirements in terms of you're telling folks you're trying to comply by telling I'm here at this time and this is what I'm flying. And I think that was missed in the initial in the rule. There's a couple other pieces too. For example, uh, it goes by a number name, but protected operations, like operations flying below like tree level, and below the level of your house or something like that. I think that those need to have special consideration in terms of remote ID too. Um, I think it's gonna be great to sort of push the industry forward because, of course, remote ID was the key linchpin before you start seeing operations over people, and then eventually beyond visual line of sight and those type of operations. So this was the cornerstone upon which we will build everything. And I think over the next 15, 20 years, maybe even sooner, we're going to see some amazing things. And just to give you an example, Zipline. Vic and I had the chance to watch a real time sort of interview with some folks at one of their facilities in Africa. And it was mind blowing. Um, just to see drone delivery happening on that scale for medical delivery was amazing. So there's a bright future, but it's going to take time. But there's some really cool things coming.
I like that. Agreed. Thank you both for joining me today and sharing your insights on remote ID.
Thank you for inviting us.
Yep, thank you.